Hello, my name is Courtney Como, and I will be bringing you up to date on the new communications platform and communication platform for open systems features that are available in ClearPath OS 2200 Release 18.0. Some of these new features are available in both CPComm and CPCommOS, and some are not. This presentation will cover the common features first, CPComm only features second, and the CPCommOS only features last. Let's cover the new features that are available in both CPComm and CPCommOS. Prior to the introduction of the Start Runstream feature, every time you install CPComm or CPCommOS, the Start Runstream provided by the product ST CPComm X, where X matches the installation mode A through H, was overridden. This meant that any changes a site administrator made to the Runstream were lost. Typically, an administrator edits the Runstream to add the file location of the CPComm or CPCommOS configuration. This feature implements a method for the administrator to provide the configuration in a specific file element, CPComm $config$.cpcomm-x for CPComm, or CPCommOS $config$.cpcomm-x for CPCommOS. The ST CPComm X runstream attempts to use the specified element. If the element is not found or is not readable, the default configuration, config source, is used. This feature also adds a unique run ID for each ST CPComm X runstream, seen in the first line of this slide. Prior to the introduction of this feature, the ST CPComm X runstreams all had the same run ID, CPComm, which made it difficult to determine which modes were running. The run ID is now CPCX, where X matches the installation modes A through H. The red text denotes the changes made to the ST CPComm X runstream. The SSL TLS component in previous versions of CPComm and CPCommOS supported TLS versions 1.0, 1.1, and 1.2 by default. If your application required SSL version 3.0 support, you had to specifically configure it for use in the CPComm or CPCommOS configuration. You use the protocol desired field in the SSL TLS security configuration statement to specify the versions of SSL TLS protocol that are allowed. You can configure specifically desired protocol versions, and you can also omit this field or specify all, both of which mean that CPComm or CPCommOS allows a default list of protocols. This default list no longer includes TLS 1.0. If you need either SSL version 3.0 or TLS version 1.0, you must specifically configure them by naming them on the protocol's desired field. If you use the default list and an application has problems opening TLS connection after upgrading to this level, it likely means the application does not support TLS version 1.1 or 1.2. Be prepared to configure TLS version 1.0 in this case, or investigate whether the application can be updated to use a newer and more secure protocol version. If you enter a traceroute command that specifies either TCP or UDP in the protocol field, CPComm or CPCommOS selects the destination port number for each use in contacting the remote system. You can select a port number on the command by specifying the port field. This feature adds a command response message that indicates which port was used to contact the remote system. Knowing the port number can be quite useful for submitting successful traceroute commands. For example, you can use this information to help you determine which ports are being blocked by firewalls. In previous releases of CPComm or CPCommOS, when TCP tracing is set to medium, 84 bytes of the input or output are captured. The smaller amount was seen as adequate and less burdensome than the tracing of all data that occurs when TCP traces are set to high. However, 84 bytes may not be enough to capture a useful amount of the application protocol for the diagnosing of some TCP issues. The following slides show examples of how tracing twice as much data can markedly improve the value of TCP tracing on medium. The first two slides will show without the new feature and the following two with the new feature. This is the old trace of 84 bytes. Notice that some of the user data is traced. Here is a new trace of 168 bytes. You can see that even more of the application data is traced. This extra data can be quite useful if the application has a control header. Now let's cover the new features that are available only in CPComm. The resolve command allows you to determine the IP address associated with a domain name or the domain name associated with an IP address. CPComm determines this association by querying the local DNS host file or by querying DNS servers. Previously, CPComm presented information about the association but did not give any information about how it derived the resolution for the association. In other words, you had no way of knowing if CPComm derived the resolution from local host files or from a remote DNS server, or which DNS server provided the resolution. Knowing this information can be important, especially when you are trying to determine which entity might be providing incorrect information. With this new feature, CPComm displays information about how the query is resolved. If the local host file provided the resolution, CPComm states that. If a DNS server provided the resolution, CPComm displays the IP address of that server. If the resolution comes from CPComm's internal DNS cache, CPComm displays that information and also provides information about the original source of the resolution. A status command can output a lot of information, especially if there is information that applies to a process. If there are enough processes configured, the output from the command may be lengthy. Many commands already allow the output to be restricted to just information on the command specified process. This feature adds this capability to 6 pre-existing commands shown here. Entity tracing is already available for several tracing components. This feature adds entity tracing support for 3 more trace components: API SSL, API TCP, and API UDP. For each of these, the entity type you can now select is a process name. Entity tracing allows tracing to be more focused, so that information you are not interested in is not traced. You can turn entity tracing on using the trace field of the admin configuration statement or by user command. For the 3 enhanced trace components, here are several examples showing how you specify entity tracing for a process. Here is an example of how to configure entity tracing for these trace components. Now let's cover the new features that are available only in CPCommOS. CPCommOS can have different names for your NIC interfaces from what SAIL has. Sometimes this can make things confusing when CPCommOS displays a name for the interface that does not match any name in SAIL Control Center. To help solve this problem, when a NIC interface link fails, CPCommOS displays both the CPCommOS name and the SAIL name if they are different. Because the SAIL CC web interface provides only the SAIL interface name, the improved information in CPCommOS message allows administrators to more easily correlate SAIL and CPCommOS interface names and troubleshoot connection issues. The additional SAIL interface name can be seen highlighted in the example. CPCommOS now supports the additional highly desirable Cipher suites on connections that use the TLS 1.2 protocol. These new Cipher suites use the elliptic curve algorithm, which can improve performance by providing strong security with smaller keys than RSA or DSA. The new Cipher suites are listed here. The availability of elliptic curve allows you to use elliptic curve signed certificates and private keys. You configure these by using new configuration fields on the SSL TLS security configuration statement. The fields on this configuration statement allow you to configure certificates and keys that employ elliptic curve, RSA, and DSA algorithms. You can allow multiple certificates to maximize the interoperability of your TLS applications. When you are using the SSL TLS protocol, it is important that you know which Cipher suites and protocol versions you are using. Some applications might be using weak Cipher suites or protocols. Using this new command functionality to identify such cases and check if remedial actions are effective. As with all the status SSL commands, you can substitute TLS or SSL TLS for SSL. CPCommOS displays messages when link or bond state change at CPCommOS startup. The previous value was 5 seconds. In most cases, this was enough time to allow for the fluctuations to subside and for the link and bonds to reach a stable state. However, this was not always enough, especially if a site had a particularly complex set of links and bonds configured. With this feature, administrators can use the NIC message timer field on the admin configuration statement to configure a longer delay before CPCommOS displays these potentially alarming intermediate state changes messages, sometimes considered false alarm messages, for NIC interfaces and bonds at CPCommOS startup. Sites that have a more complex CPCommOS configuration, including a large set of NIC interfaces or bonds, can suppress intermediate state changes messages by configuring a longer wait time. Prior to the introduction of this feature, CPCommOS delayed messages for 5 seconds, which is insufficient for more complex configurations. With this feature, an administrator can delay the message for up to 30 seconds. This concludes this presentation. For additional information, contact Unisys representatives.